Look closely at this star, a beacon of light, a titan of the cosmos burning for billions of years. But what if I told you that within its fiery core, a silent, irreversible countdown has already begun? What if the very forces that sustain it are now conspiring to tear it apart? And what if, in its final, cataclysmic moments, this star holds a secret that defines our very existence? We stand on the precipice of an event so violent, so powerful, it defies human comprehension, an event that will reshape the fabric of space and time. But before we witness its ultimate demise, we must ask what truly happens inside a star when it takes its final breath. For billions of years, stars like our Sun, and even giants like the one we just saw, live a life of fiery brilliance. They are cosmic furnaces, tirelessly converting hydrogen into helium through a process called nuclear fusion. This fusion generates an outward pressure, a constant push against the immense inward pull of gravity. It's a delicate dance, a perfect balance that defines a star's stable existence, but this balance, this cosmic equilibrium, is not eternal. Every star, no matter how grand, carries the seeds of its own destruction within its very heart. As a star ages, it begins to exhaust its primary fuel, hydrogen. It then moves on to fuse heavier elements like helium into carbon and carbon into oxygen. Each new fuel source provides a temporary reprieve, a brief extension of its luminous life. For massive stars, those at least 8 times the mass of our Sun, this process continues, building up layers of progressively heavier elements like an onion. Iron, however, is different. When a star's core becomes predominantly iron, fusion stops. Iron fusion consumes energy rather than releasing it, marking a critical turning point. The star, for the first time in its long life, begins to lose its fight against gravity. The star, once a symbol of stability and light, now faces an existential crisis. Its internal furnace, once its lifeblood, has turned against it. The outward push weakens, and gravity, relentless and unforgiving, begins to win. The core, no longer supported by the energy of fusion, starts to collapse. Slowly at first, then with an accelerating, terrifying inevitability. But this isn't the end, not yet. This is merely the prelude to something far more spectacular, far more violent than anything we can imagine. The star is holding its breath, and the pressure is building. What happens when it can hold it no longer? The iron core, now compressed to an unimaginable density, reaches its breaking point. In a fraction of a second, a mere blink of an eye, it collapses. Not slowly, not gently, but catastrophically. It shrinks from a sphere the size of Earth to a super-dense ball just a few miles across, a neutron star. The speed of this collapse is mind-boggling, approaching a quarter of the speed of light, but the story doesn't end with a whimper. It begins with a bang. As the core collapses, the infalling outer layers of the star crash into this newly formed, incredibly rigid neutron star. They don't just stop, they rebound. Imagine a cosmic rubber ball, compressed beyond its limits, springing back with unimaginable force. This rebound generates a colossal shockwave, a wave of pure energy that begins to tear its way outwards through the star. This shockwave is the engine of destruction. It slams into the layers of gas and plasma, heating them to billions of degrees. Nuclear reactions, previously dormant, ignite with a ferocity never before seen. Elements forged over billions of years are now ripped apart and reassembled, creating new, heavier elements: gold, silver, uranium, the very building blocks of planets and, indeed, of life itself. The star, once a gentle giant, is now a cosmic cannon. The shockwave accelerates, pushing the outer layers of the star outwards at incredible velocities, tens of thousands of kilometers per second. This is not just an explosion, it's a cosmic detonation, a blinding flash of light that can outshine an entire galaxy for a brief, glorious moment. It's the ultimate fireworks display, a final, magnificent roar before silence. This is the supernova, the violent, glorious death of a star. But why does it matter to us, here on Earth, billions of miles away? What is the profound secret this dying star holds for our existence? The answer to our initial question and the profound secret held within. The dying star lies in the very dust and gas it expels. When a massive star takes its final breath in a supernova, it doesn't just die, it becomes a cosmic alchemist. The immense pressures and temperatures within the explosion forge elements heavier than iron, elements like carbon, oxygen, nitrogen, and all the precious metals that make up our world, our bodies, and everything we see around us. We are, quite literally, stardust. The iron in our blood, the calcium in our bones, the carbon that forms the very basis of life, all of it was forged in the heart of a dying star, flung across the cosmos in a supernova, and eventually became part of the raw material from which our solar system and ultimately us were born. The violent death of one star is the fertile ground for the birth of new ones, and with them, the potential for life. So, what truly happens inside a star when it takes its final breath? It doesn't just explode, it gives birth. It sacrifices itself, not in vain, but to enrich the universe, to sow the seeds of future generations, and to remind us that we are all intimately connected to the grand, violent, and beautiful dance of the cosmos. The universe is not just expanding. It is evolving, constantly recycling, constantly creating. And in every atom of our being, we carry the legacy of a star's final, magnificent breath.